Hey everyone. So you've probably been there. You ask an AI a question and it gives you this super confident, beautifully written answer that's completely wrong. We call those hallucinations. Today we're going to dig into a really powerful idea. What if the best way to stop AI from lying isn't about making the AI smarter, but about first building it a much clearer, better defined world to live in? Let's get into it. Right. This is the big question, isn't it? It drives everyone crazy. You ask for a simple fact, and you get back pure fiction. And it really feels like the AI is just guessing. Well, here's the thing. In a lot of ways, that is exactly what's happening. So let's frame the problem this way. We like to think of AI as this kind of artificial brain, right? But honestly, for a lot of the systems we use today, it's way more accurate to call them incredibly sophisticated guessing machines. They are absolute masters of probability, but they're not really thinking or reasoning. And there's a really deep reason for that. Yeah, this isn't just some temporary glitch we can patch with the next software update. As the philosopher Barry Smith points out, this is a fundamental mathematical problem. The kind of clean, formal logic that we use to build AI systems is just on a completely different planet from something that is messy, emotional, and totally unpredictable, which, is us, human language. And this really gets to the heart of it. Machines are fantastic at modeling simple systems, like the solar system. The rules are fixed, they're predictable, context doesn't matter. But human language, our culture, our behavior, that's what you call a complex system. It depends entirely on context, it's always evolving, and you can't perfectly predict what's coming next. So trying to model our messy world with the same tools we use for planetary orbits, yeah, you're going to have a bad time. And here's a perfect example of what that looks like. An AI is trained on thousands of pictures of school buses. It learns a very specific pattern of yellow, windows, and wheels. It doesn't actually understand the concept of a school bus, what it is, what it does, or that, it's still a bus, even if it's tipped over on its side. It's just matching a pattern. And when that pattern breaks, the whole thing falls apart. That's the guessing game in a nutshell. So this pattern matching problem leads us straight into our next big issue, what we can call the language trap. What happens when you feed the messiest, most ambiguous, pattern-defying dataset into one of these sophisticated guessing machines? Well, you get chaos. I mean, just think about the raw material we're giving these AIs to work with. Our language is just packed with slang and sarcasm and words that mean 5 different things. And words are always changing their meaning. Researchers have a term for this. They call it distribution drift. The word cool meant something completely different in the 1950s than it does today. We're asking a machine that needs logic and consistency to make sense of this beautiful, glorious mess. So here's the key takeaway. There's this huge gap between the words we use and what we actually mean. A project manager types, need to get the app out soon. But their real goal? It's specific, it's structured, it has a hard deadline. The AI only sees the text. It has to take a wild guess at the actual intent underneath. And that's where things start to go wrong. And we've all felt this pain, right? You're trying to deal with a customer service chatbot, and as long as you stick to the exact script it expects, everything's fine. But the second you have a problem that's even slightly unusual, the whole system just breaks down. It doesn't understand your goal, it only recognizes keywords, it's a guessing machine. And once it runs out of patterns it knows, it's game over. Okay, so that's the problem. It's a big one. But what if we've been coming at this from the wrong direction entirely? This is the core idea behind ontology. You define reality for the AI before you let it start playing around. Think of it like this. It's giving the AI a super detailed map and a dictionary before you send it into a new city, instead of just letting it wander around lost and guessing where to go. And the most basic tool for this is something called a controlled vocabulary. It's a really simple idea, but it is so powerful. You basically just take the chaos of everyday language and you impose some order on it. You officially decide that laptop, notebook, and portable computer all mean the same thing. You clarify that the word bridge, as in the thing you drive over, is totally different from bridge, the card game. You create one single, unambiguous source of truth. And you can actually build this model of your world piece by piece. You can start with just a simple list of terms. Then, you group the synonyms together. After that, you build a taxonomy, organizing things into hierarchies, like poodle is a type of dog. And finally, you can build a thesaurus, which adds all sorts of other relationships, like dog is related to kennel. You're literally building a map of a specific reality, step by step. And this is what that looks like when you put it into practice. This isn't just a list of words. It's a structured model of knowledge. It explicitly says that a mental process is a type of organism function, which itself is a type of physiologic function. For a machine, this is pure gold. There's zero ambiguity here. All the relationships are laid out perfectly clearly. Okay, I know this might all sound a little bit academic, but it has some unbelievably powerful real-world uses. So let's look at how defining reality first can solve some really concrete business problems and move this out of the world of theory and into the real world. Let's say you're a food manufacturer. An AI looking at this table just sees a bunch of check marks. It might not know that walnuts are a type of nut. So if a customer asks for nut-free products, the AI could easily and dangerously recommend the walnut biscuit because that relationship isn't explicitly defined. This is the kind of hallucination that can have serious consequences. And this same idea works everywhere, not just in manufacturing. Think about e-commerce. A customer is clicking around on your website. They look at a few items, they use the search bar, they add something to their cart. Each one of those actions is a separate data point. The whole goal is to connect all those dots to figure out not just what they're clicking on, but why. What's their goal? And to solve that, we build what's called an intent graph. It's literally a map that connects all those dots. It explicitly links a specific user to their sessions and those sessions to the products they look at. By mapping out these relationships, the AI doesn't have to guess what a user wants anymore. It can just follow the connections we've already defined and see, they're probably looking for a blue, medium-sized t-shirt. We're structuring the reality of their journey. And this is the after state. This is what happens when you really apply ontology. Just look at this network. It's not a list. It defines that a cell is part of a tissue, that a finding is an evaluation of an anatomical structure. Those relationships, the ISA, the part of, the disrupts, that's the most important part. You've taken this raw, messy data and turned it into a real knowledge map that a machine can navigate with confidence instead of just guessing its way through. Which brings us to our final, and maybe most important point. The path to AI we can actually trust isn't about chasing some magical, super intelligent model that can do anything. No, it's about a much more disciplined, structured approach. It's about choosing solid reason over wishful magic. So the ultimate goal here is to completely shift our focus. Instead of building these clever guessers that we just hope will work, we need to start building fundamentally reasonable systems. Systems that operate within a world that we have already taken the time to make clear and understandable for them. And the skills you need for this are different. It's about replacing all that ambiguity with certainty. It means doing the hard work of formally mapping out your domain knowledge. And critically, it means you stop your AI from trying to guess the fundamental structure of your business from constantly changing unreliable stuff like marketing copy. You define the structure first. You are in control. And look, this isn't something you do just once and then forget about. A business's reality is always changing. New products come out, new terms pop up. This knowledge map is a living, breathing thing that has to be managed. You need what's called taxonomy governance, clear rules and policies for how this model of your world grows and evolves to make sure it stays accurate and useful for your AI. So I just want to leave you with this one final thought. The race to build bigger and more powerful AI models it's fascinating. But for building practical, reliable systems that work today, maybe we've been asking the wrong question all along. Maybe the real challenge isn't about the cleverness of the machine, but about the clarity of the world we're asking it to understand.